Welcome, or hopefully welcome back to another episode of Reliability Matters, the podcast where we dive into the people, practices, and principles that keep our technology and our industries and our products reliable. For those of you who are counting, this is episode number 170. I'm Mike Conrad, and today we're exploring the concept that has deep roots in process safety and infrastructure management, but also has meaningful applications to the electronics manufacturing industry: damage mechanism reviews, or DMRs. My guest today is Dheeraj Narang, a corrosion and reliability engineering specialist, process safety activist, and digital innovation researcher with an impressive track record across the energy sector. Dheeraj has spent his career developing and implementing asset integrity programs designed for more than 9 global energy companies across the US, India, and the Middle East. He's also a visionary advocate for using advanced technologies, industry best practices, and safety standards to uplift regions and workers where such systems are still under development. Whether it's through his service on global conference committees or his contributions to cutting-edge digital initiatives, Dheeraj is on a mission to blend technology, safety, and human rights into a unified vision of operational excellence. In this episode, we'll discuss what damage mechanism reviews are and why they matter, how DMRs tie into reliability programs like FMECA, how DMR thinking could benefit industries outside of oil and gas, including the electronics manufacturing industry, and how emerging technologies like AI and machine learning can amplify the impact of these reviews. So whether you're in energy, electronics, or any industry where reliability and safety are paramount, this is a conversation you won't want to miss. Let's dive in.
Welcome to Reliability Matters, a podcast for the electronic assembly industry. Each episode covers topics related to reliability, best practices, and environmentally responsible assembly techniques, with insights from experts across the electronic assembly industry. Now, here's your host, Mike Conrad.
Hi, Dheeraj. Welcome to the program.
Hi, Mike. Thank you for having me. It's good to be here.
Yeah, it's good to have you. All right, let's dive in. I have to admit, I've heard of a lot of DF, MDF, all these different things. DMR was new to me. Let's kind of start at the beginning. What is damage mechanism review, or DMR, and why is it important for reliability in both process industries and potentially other sectors like the electronics industry?
Yeah. Thank you so much for taking out the time and having me here. Let's look at the name itself, damage mechanism reviews. So it's a mechanism that, will help you identify the damage modes in your, particular process. Now, it can be any process. It can be a process plant. It can be a distillation process in, oil and gas. It can be a petrochemical, silicon manufacturing process, or it can also be a electronic device or a medical device manufacturing process. So if one has to look at the textbook definition of DMR, it's a process where you identify the damage mechanism and identify the damage modes, failure modes, and the related consequences scenarios to have like a broader picture of how your production process will operate and how it can fail. So it is closely tied with the reliability aspect of it, because if you look at the definition of the reliability, it's like you want your asset to do what it's intended to do, like over the life cycle. So if it doesn't do, that means it's failing in some ways. So one of the failure modes, or a way of failing, could be damage mechanism that a material experiences in a processing plant.
Excellent. And give me a little bit of insight into your background. How did you fall into this DMR space?
Yeah. So by academic training, I'm a mechanical engineer. I have a master's in mechanical engineering with a focus on advanced thermodynamics and material behavior. So my exposure to DMRs began with my career in asset integrity management for oil and gas, petrochemicals, and fertilizer manufacturing facilities. So that's where I began making asset management plans. Then I moved into risk-based inspection planning. Now, I identified over the course of my career that there is a trend that everything, all types of assessments go deep, and the central point is the damage mechanism. What is the asset experiencing the damage mechanism? So once that is identified, all the reliability engineering practices fall into place. So that's how I bumped into the DMR.
And what are the primary benefits? We touched on some of them of conducting DMRs, and how can organizations ensure they're fully realized? The benefits are fully realized.
That's a very good question. So if you look at the benefits, DMRs help two ways. One is the process safety management compliance aspect of it, and the other one is the actual reliability aspect of it, reliability improvement. Because most process plant facilities are covered under OSHA PSM compliance. Now there are threshold quantities of certain chemicals, which it could be flammable, it could be toxic, and if you exceed those threshold, it's classified as a PSM covered facility. Now, now those are one set of applications. But what if you have concentration below those thresholds? The asset is still going to experience damage, right? So that's why the second benefit of DMRs is it helps you make sound reliability engineering plans for your assets.
Great. Can you walk me through an example of using DMRs to implement a reliability best practice like FMECA?
Yeah, sure. So if you look at the DMR framework, you will see there is a central, DMR, and then it flows into two places. One is process safety management compliance, and the other one is reliability engineering. Now, let's pick one of the, reliability engineering best practice. Let's call it failure mode effects and criticality assessment. It's, famously known as FMCA. So if you see FMCA, it has a fundamental aspect, a method of calculating the RPM, the risk priority number. Now, how does one arrive at a risk priority number? You have severity, occurrence, and detection scales. Now, these scales will be defined as per the facility, type of facility, whether it's a electronics manufacturing, whether it's a silicon manufacturing, whether it's a oil and gas. Once you define, once a reliability engineer defines those scales, the occurrence part of it and the severity part of it will be closely tied with the failure mode, the way it fails, and that's where the DMRs come into picture. So to give you a very specific example, for an air fin cooler in a refinery, say you have ammonium bisulfide corrosion. Now you can see the criticality of that asset, what it's cooling actually, and whether it impacts the product quality, heat duty, or other types of containment issues. So one can develop an FMCA plans, criticality, complete the criticality assessment using FMCA, with the DMR framework being central to it. So that's one application, specific application.
So it's kind of a prioritization, right? You're giving it a scale of this thing really can't fail, or this thing is not a big deal if it fails. So a priority can be put on maintenance and inspection and things like that. Is that a good restatement of what you just said?
Yes, that's exactly right. So ultimately, all reliability engineering best practice will do three things. It will help you do risk assessment, and then based on that risk assessment, you will do inspection, maintenance, repair, on replacement planning. People also call it asset strategy management, integrity management, reliability plans, etc. Yeah.
And are those generally scaled on a 1 to 10, 1 to 100, 1 to 1,000? Is it a simple scale in terms of prioritization?
So that's a very good question. So it varies from the industry to industry. So for example, API 581 is the risk-based inspection methodology. RP, they call it RP. API calls it RP. It's American Petroleum Institute. RP stands for recommended practice. Now it has predefined scales. So if a facility doesn't have their own in-house technology or a risk assessment process tying back with the damage mechanism, they can, those facilities can readily use those. Now, in terms of, say, electronics manufacturing or any kind of a, production line manufacturing, people also use, OEE, overall equipment effectiveness. There you have performance, availability, and yield. So in calculating your yield, you're going to remove all the defective parts. That's where also, DMR can also help.
Interesting. How do you identify and prioritize damage mechanisms in complex systems? I know the petrochemical industry is we think our industry is very complex. I think that is equally, if not more, complex. So how do you identify and prioritize these mechanisms in complex systems such as chemical plants or, for that matter, circuit assembly manufacturing that may be exposed to harsh environments, particularly in the petrochemical world? I mean, that kind of lives in a harsh environment, but it creates its own harsh environment. But how do you go about identifying and prioritizing those things?
That's a very good question. So let's break the DMR process down into 4 steps. The first would be collecting data. So reliability engineer would collect all types of data, say process flow diagrams of the process unit in question, process piping and instrumentation diagrams, material specification, the inspection, test plan, and quality assurance and quality control documents when the equipment was manufactured and commissioned. Those times, those documents as well, and any operational / inspection history. And then a corrosion specialist is required to go through the American Society of Metal handbooks. I'm just giving out specific examples. It could be different documents, a whole range of more documents depending on the industry. And the corrosion specialist has to benchmark the current production process, their operating windows with the actual corrosion testing data available in the industry. Now the unique part is that sometimes there is no corrosion testing data available for that particular specific process, like you cannot find. So one has to like approximate and become like a use thought leadership and subject matter expertise to arrive at a particular damage mechanisms. Now one has to keep in mind you can have 5 different damage mechanisms on a same set of distillation column, or say a reactor. Not all 5 of them will have the same severity. So there is one could be a driving one, and one could be like is going to augment the damage done by the main damage mechanism, if that makes sense. So that's the whole process. And then one can tie it into, like we discussed earlier, into process safety management, do process hazard analysis and be compliant, and also go the other way and do reliability engineering best practice implementation.
Are there specific triggers or intervals that should prompt a DMR in a healthy reliability program?
Again, I have a very good question. So its short answer is yes. So OSHA PSM mandates process hazard analysis every 5 years. As part of those hazard assessments, one has to do scenario development, and then one has to go back and see if the same damage mechanisms apply, or the asset has been repurposed to a different process, and it's operating at a very mild condition now. Because keep in mind, like a typical refinery has too many heat exchangers. Not all of them are critical from the safety and process point of view, so they can just repurpose and use it in a different unit. So that's one. Yes, that can be a general compliance driven trigger. The other one would be if a facility is really a pace setter operational facility. Now when I use the term pace setter, it means it's going to operate in quadrant 1 with respect to an industry benchmark. And I don't really seem to recollect the industry benchmark. Yeah, Solomon Associates. So Solomon Associates have industry benchmark quarter 1, 2, 3, and 4. So quarter 1 is the best reliable assets. So if a site is implementing those measures, the damage mechanism previews can come in handy. So any type of a major process deviation from an already established integrity operating window would trigger a DMR assessment. And not all the DMR assessment has to be exhaustive. So if you do it once, then it's going to become a like continuous improvement process, and then you will have like a half a day or a 1 day workshop, and then revalidate those DMRs again.
What role can AI, artificial intelligence, and machine learning play in enhancing DMRs or DMR-driven safety and reliability programs?
Uh, uh, that's a good question. So, as part of my PhD, I'm also like researching on applying artificial intelligence and machine learning for implementing reliability best practices. One of the the good thing about simplifying the risk-based inspection process, which is solely based on the damage mechanism, is you can readily use supervised machine learning models. Now, to build those more models, you have to code the data that you collect, the qualitative data in terms of repositories, inspection reports. Some would be in digital format, some would be in old files. You have to scan it and review it. Some would be from ASME, American Society of Mechanical Engineering codes, or API RPs. But you can code that and simplify it and make a machine learning model to predict whether your damage mechanism will exceed a certain amount of pre-established risk or not. That's very prevalent nowadays. There are also like couple of challenges with that process. Doing automated risk-based inspection study based on DMR. But I think eventually those obstacles will be overcome easily.
How can companies avoid making DMRs just a checkbox activity? We're just going to check the box and move on. We're not really caring what the results are, and instead use them to drive really meaningful improvements.
Mhm. That's covered in the effectiveness part of it. So and when I published my paper, dual benefits of damage mechanism review, in the global congress for process safety conference last year, I touched upon this aspect a lot. A site can have a DMR done in an Excel sheet, to be honest, and a site can also have a fully blown machine learning driven damage mechanism review process. So it really depends on the goals of the assessment. If a site is only doing DMRs to find out whether your asset will run until the next schedule shutdown, I wouldn't do an extensive DMR. I would just do a one-time DMR, documented, give a specific report number, and then keep it there so that the site can run that asset until the next schedule shutdown. Now, if it's like a regular program which is driven by corporate and it's implemented by multiple facilities with that company, then it makes more sense to do a full exhaustive damage mechanism review. So it will have right from the data collection. You will have like 5 to 7 workshop for one process unit, and then you will have meaningful inspection planning. Uh, you know, Down the line, that will cover at least 2 shutdown cycle. That's the industry benchmark, 2 turnaround cycles, which is around 10 to 12 years for a mid-sized refinery.
So I'm just curious, and you're familiar with the refinery space, so I'll ask you based on that. In that industry, do they typically use outside contractors to perform DMRs and come up with the criteria, or do they do all that in house? Do they hire people with your experience, for example, to do that, or is it generally speaking a contract type business?
It's a combination of both. I would say a company with a well-established central engineering division, they typically have their own process. So even though they would hire contractors, they will need to come learn their process and implement on their behalf. But there are like smaller scale companies, say, I cannot name a company, but say, a company only has like 2 refineries or 3 refineries in the US. So they will not have a central engineering division, and most of the small scale facilities are repurposed from a legacy big company, like it can be a ex Exxon or it can be a ex Shell. So in that case, they rely heavily on consultants and external subject matter experts to not only do the program for them but build technology to have a long term continuous improvement driven program. Yeah.
So remember several years ago, I believe it was ExxonMobil, maybe you can correct me, they had that platform blowout, for lack of a better term, which put millions of barrels of oil into the ocean, and it took them weeks to stop it. And
Mhm.
that seems to be the perfect poster child for DMR. Uh, are you aware of that event? And if so, in your opinion, we're all hypothesizing here because none of us were on that platform, thankfully.
Mhm.
But did that seem to stem maybe from a lack of DMR, and would a good, healthy, robust DMR program, would that likely have stopped that event from occurring?
That's a very good question. So I think it was British Petroleum, and their platform was
You're
in deep
right.
water.
You're right. Yeah, it was. Yeah, it was
Yeah,
BP. Yeah, sorry, Exxon.
yeah.
It was BP. Let's get that right. Yes.
Yeah. But one has to keep in mind, that accident is a famous one. That's why people talk about it. There are there are a lot of like small scale incidents which shouldn't happen in the first place itself, even though it doesn't result in ultimately, major failure scenario. So I would say yes. I think in that case, from my memory, because I have been like watching videos for that incident as well early in my career, and I think it was mostly because of a blowout preventer which didn't work the way it should work, and damage mechanism review could have easily prevented it. So one aspect of DMR is also like scenario development. So what it does is, like, say for example, there is an initiating event. So say, you found one finds damage in the blowout preventer on an oil platform. Now what does happen like after that? Can it be monitored? Can the damage be monitored and still run? Do we have to like bring the platform down? Can we use a spare BOP, shut this one down? So those kind of, like a detailed process also help. And if it's a well embedded DMR, even the operational guys on the field would know, these are the scenarios and we can do this. So yeah, I agree. Like all incidents, all process safety incidents which could classify as a significant and a major, I think these are defined by OSHA, can be easily prevented, with the help of the DMRs.
So apparently there were mistakes made on that platform that day. So on the subject of mistakes, what are some of the common mistakes or misconceptions that you see when organizing, when making a first attempt to organize and implement a DMR?
That's a very good. This falls again into the effectiveness aspect of it. So one of the biggest pitfalls I've seen, I would say two of the biggest. The first one would be a site or a team, wanting to implement DMRs need, a corrosion specialist. It's a must, and sometimes, people ignore that, and they think that, a process engineer can identify a DM, a mechanical engineer can identify a DM, but no, you need a formal training. So even with my master's in mechanical engineering, I had to go and learn about NIST corrosion technologist and pass that, competitive exam to be able to, sit on the team as a corrosion specialist. So that's one. Second would be the need of, effective data collection. So if a site has, very good data, half of your, issues will be over in terms of efficiency later on, because you're just going to build on it. But if you don't have the data, then a lot of assumptions go into place, and the risk assessment, the RBI, the slash reliability engineer would most likely going to lean on the higher side of the risk. And initially a site needs to spend more money to know more to bring the risk down, because if you know more, there is a term called inspection effectiveness, in the world of reliability engineering for oil and gas. So if you know the effectiveness of your inspection, if you have good data, your risk goes down because you know more. So these two, I would say, two of the biggest pitfalls that, commonly ignored by teams, wanting to do DMRs.
In our industry, we have a term, probably other industries too, we have a term called Industry 4.0, which is basically having data flow between equipment, where every machine kind of talks to every machine, and then something's collecting all the data and then discerning and analyzing the data, and hopefully someone reacts to that data. I'm sure there's something similar in other industries as well. In your world, in the world that you're experienced with, which is the petrochemical business, is that a common theme? I view from the 30,000-foot complete layman view, these petrochemical plants to be a mixture of steel and iron and oil and sludge and dirt and some, modern electronics hardware. And there's probably a little bit of accuracy to that. But are they today, is every piece of equipment collecting data, sending data somewhere? Do machines talk to each other the way they do now in our industry, in the electronics industry? Is that here? Is that present in modern petrochemical plants?
Yes, extensively. So I'll give an example, for the DMR, damage mechanism review. So damage mechanism needs to be identified. But once you identify it, what is the extent of it? So that's where, corrosion probes and, corrosion coupons come into play. And some of the corrosion probes are actually IoT devices, and they send data directly to digital control system in the plant. So that's a very specific application for as it relates to DMR. But even other than that, to monitor the continuously the pressure, the temperature, all of the main fundamental physical parameters go into DMRs, and those are also heavily collected or automatically. I'll give you another example. There is an Aviva platform which is widely used in refinery. So it's like an interactive module. You can click on an equipment. It shows you real time what is the temperature and the pressure. So one can see if it is exceeding your integrity operating windows, which was defined based on the DMR done in the past. So that's another example. And there are a lot of digital process control softwares available, and those can directly talk to DMR assessments. Now, few of the data integration could be manual, because the purpose of collecting a process control data is different than doing DMR. But some of it it relates directly to DMRs. Like I give an example of corrosion probe. Another example would be any kind of automated inspection data, like automatic automatic ultrasonic inspection. So if you have a tank, it's a very, very huge tank. You're not going to go and manually collect the data. Otherwise, it's going to take like 4 months just to collect the data.
Sure.
So you have this crawler. You mount your AOT probe, and then you just prepare the surface, and it just rolls around it. Takes turn, goes above, come back, and all the data is fed into the system. An engineer still needs to flush that data and remove all the anomalies and have like a good data. But those things are heavily automated in processing industries.
Yeah, I think that's back. I remember when I first got into the electronics industry 40 years ago. We had a piece of equipment in a memory module manufacturer for PCs. This is back when when chips were made in the U.S. Long ago, and there were metal detectors in the building. You didn't go through the metal detectors on the way in. You had to go through the metal detectors on the way out, because memory was so expensive that if I reached into a bin and grabbed 10 or 20 small cards, memory cards, and shoved them in my pocket, those were worth thousands of dollars on the street, right? Now memory it's cheap. If we rounded down, it would be free. It's super, super cheap now. And as a result, we're collecting lots of data for two reasons. A, because we can, and B, because memory's cheap. We don't have to discern what data we're collecting. We just collect everything and then decide later how to parse it and discern it. And that has created a whole new problem, because we have terabytes and terabytes and terabytes of data. Now, what do we do with all this? That's the category of what we refer to as big data, right? Now, what do we do with it? And I think, to an earlier question, I think that's where AI probably comes in, because a human, even if we're collecting all that data, to your earlier point, it could take months, if not years, to decide what data is worth analyzing, what data is junk data, what data, what are the anomalies, what's important, what's not important. We almost have to prioritize the data we're collecting. And And has that landed in your world that there's just too much data and it's overwhelming to figure out where to which data is important, which isn't?
That has certainly been an issue with what I'm doing as per part of my PhD research. So I'll this is a very interesting question. So I'll talk about a technique called retrieval augmented generation. It's called RAG, and RAG is heavily used with large language models. So when we talk about artificial intelligence, you go in increasing complexities to mimic the human like behavior. And right now the best model is, so you have supervised machine learning, you have unsupervised machine learning, you have deep learning, and then if you go into further complexity, it becomes a transformer which can do reasoning like a human. So that's why we have the LLM. So that's just a brief for the audience. Now so if you have say 65 OEM manuals and you're retrieving information to make your reliability engineering plans, how do you do it? Are you going to read all the 665 manuals like
Right.
yourself or in a team? That's crazy. Even if you feed it to LLM and you ask questions, there is a chance that it could do hallucinations, or there is, depending on the LLM's capability and context window. Because remember, LLMs are different. ChatGPT is OpenAI. You have Gemini with Google. You also have Meta, Lima, and there are different. So they have the context window limitations as well. Now, when that kicks in, your accuracy of retrieval. So it's going to still retrieve and give you something, the LLM, if you feed all the 65 manuals. But what is the accuracy of that retrieval? Is it like accurate enough? Can it pull the information right towards the end of the document, or it can only do certain extent depending on the context window? So that's a research problem that I'm currently working on, and it's based on retrieval augmented generation to do data processing on OEM manuals for creating reliability engineering plans for the oil and gas and other chemical processing assets. So it's a very big problem, and those things are still in progress as of today. But hopefully by the end of this decade, we'll have something sound for that as well.
Sounds like it's a 20-year PhD program, Dheeraj.
Well, most likely I'll be done hopefully before that. I'm talking about the industry. Industry might have a sound solution. I try my best to come up with a solution. If I can, then we'll see.
So we can come up with all these technologies. We can come up with really good DMR strategies. We can come up with a good learning system for AI. We can do all that. But at some point, it all comes down to culture, right? We need to change the culture on a platform or on a manufacturing floor of some sort. So how does organizational culture influence the success of DMRs, particularly in industries under pressure to cut costs and or speed up production, which is like everybody?
Yeah, that's pretty much everybody, and especially nowadays with the tariffs and all, it's even going to be more competitive.
Yeah.
So I think I think it will go back to the first step of the effectiveness. Like, define the scope of your DMR assessment. Like, what do you want your DMR to do? Are you just going to look at the damage mechanisms on a particular piece of equipment? Is it like a one-time standalone assessment? Or are you going to integrate that DMR into a sustainable inspection plan? And again, I'm using the word inspection plan. It can be a reliability plan, asset integrity plan, production plan, whatever, depending on the industry. So if it's going to be a something that's going to be embedded into your operational / maintenance philosophy, then I would do fully exhaustive, like go into very detail and have the organizations commit resources to gain something out of it. One differentiator of a good DMR and a okay-ish DMR, like you gain something out of it, is if the facility leadership or a plant leadership looks at the DMR and assign a KPI. Like, what do you want to gain out of it? So one KPI could be, I don't want any process safety incidents whatsoever over the next 10 years. Not even a single small leak which can be detected and prevented, and a full scenario. I don't want that either. So that can be a metric to judge the effectiveness of DMR. And if the DMRs don't deliver, that can again, like we spoke, that can be a trigger for reassessing those DMRs. So that's one example, and this way, depending on what the site wants and how well organized the scope is, and the judging the effectiveness of that DMR is, site can gain a lot of benefits out of it.
If you were speaking directly to reliability engineers in electronics manufacturing, or any space, for that matter, what advice would you give for incorporating DMR thinking into their existing process and standards?
Mhm.
So talk to my industry.
I would Sure. So I would first, look at all the first step is, compliance, because you don't want to do something that's not compliant with the your industry codes. So I would look at the relevant ISOs, ISO guidelines. If it's a depending on what industry it is, petrochemical follows mostly MTIs, Material Technology Institutes. Even the silicon manufacturing plants, they also follow MTI guidelines. They have a failure mechanism, DMR library for most of the rotating compressors and pumps. You also have failure frequency libraries available. Similarly, for electronics manufacturing, or say medical device manufacturing, you have relevant IEC and ISO codes. So one has to look at what is applicable to your industry, and then contextualize the risk assessment process to incorporate the DMR. Now, the damage mechanism in an electronics or a medical device, or like a small production facility where you have similar products being made over and over. I think one would be, one can use Six Sigma or a lean method to identify the type of waste, and that's where DMR could also help. Because I think there is a process of Six Sigma. It's called design, analyze, DMAIC. So you design, measure, analyze, improve, and control. That's where exactly the DMR process falls. So DMR is design, measure, analysis, inspect, and control for processing industry. That's exactly the system method for it. So that's I would say, first contextualize it, and then you go with it, commit the resources, define the scope of the assessment. How do you going to judge the success of the program, KPIs, and then just commit to it.
So what's your plan after you get your PhD and you become Dr. D? What are you going to do?
That's a good question. I'll probably take up like a specialist or a research engineer position. With a company with Industry 4.0 solutions, and I'm also like researching, like I said, on using the artificial intelligence for improving asset management in processing industries. But I'm also leaning towards the silicon manufacturing as well, because it's also partly petrochemical. And then if you go for the downstream of that industry, it's chip manufacturing. So I possibly take up a position with one of those companies and do some research using advanced quantitative methods to improve their reliability of the production processes. I mean, after all, life is an optimization problem, right? So you're always finding optimal solution.
That's right. Yeah. Well, very good. Well, Dheeraj, thank you so much for informing me on this new D, the DMR. I wasn't aware of it. I'm a little bit more aware of it now, and it makes, in my world anyway, it makes perfect sense. And it's definitely something that I think any industry, and in particular the electronics manufacturing industry, can benefit from, if it isn't already. Maybe it is, and I just never bumped into it before. But I appreciate your insight, and I wish you the best of luck with your PhD and finding a place in the world to put that wonderful knowledge, that useful, wonderful knowledge to use.
Yep. Thank you so much for having me on the podcast. It's really, I love talking and discussing ideas. It's good to be here. Thank you so much.
Well, it's great to have you. Thank you. Well, that's another episode. Thanks for listening to or watching the Reliability Matters podcast. Don't miss an episode. Subscribe to Reliability Matters on your favorite podcast app. If you're watching this podcast on the Reliability Matters YouTube channel, be sure to like and subscribe to be notified when new episodes are released. We release new episodes on the second and fourth Tuesday of every month. A special thanks to the Printed Circuit Engineering Association's PCB Chat at pcbchat.com and Ascendo Reliability at reliability.fm for syndicating this show. Thanks also for your questions and episode suggestions. Please keep them coming. I love to hear from you. Send comments or episode suggestions to mike@mikeconrad.com. Just remember that's Conrad spelled with a K. To learn more about the Reliability Matters podcast, please visit our website at reliabilitymatterspodcast.com. Once again, thanks for listening or watching. Until next time, keep learning, keep doing it right, and remember, reliability matters. I'll see you again in 2 weeks.
Thanks for listening to the Reliability Matters podcast. Join us on the second and fourth Tuesday of each month for new episodes of Reliability Matters.